Item: SCP-357. Object Class: Euclid. Special Containment Procedures: a 10 kg seed sample of SCP-357 is to be contained within a hermetically sealed container within a 3 m x 3 m x 3 m room at Site-19. Samples removed from the container are not to exceed 1 kg. A detailed log must be kept of all SCP-357 that is produced, complete with accurate records of what had been used to feed it and how much of the sample was subsequently destroyed via compression. The mass of the container is to be monitored electronically. Changes in mass that are not accounted for by removal or return of samples will result in an automatic lockdown of that section of Site-19, as this indicates that a breach of the container may have occurred. Unless provided Level 4 approval, researchers are not to expose SCP-357 to temperatures exceeding 100 degrees Celsius. The amount exposed to these temperatures is never to be greater than 1 cubic millimeter, under any circumstances. Description: SCP-357 is a malleable substance with a density of 250 kgm3. The material has been found to reflect all radiation with 100% efficiency. To date, chemical analysis of SCP-357 has yielded no conclusive results. Electron microscopy of SCP-357 has shown no inherent granularity at any level. These two latter results suggest that SCP-357 may not be atomic in nature. However, there have been no satisfactory hypotheses as to how baryonic matter is able to interact with it. When permitted to physically interact with SCP-357, researchers describe it as having a consistency similar to that of Play-Doh brand modeling compound. However, unlike Play-Doh, SCP-357 will not retain its shape for any length of time if left at rest. It will settle at a rate of approximately 0.5 cm per minute until it reproduces the shape of the inside of its container. SCP-357 will form a meniscus inside the container 7.5 cm high. The thickness of the substance at the top of the meniscus is 1 mm, at which point it merges with the surface of the container following a Gaussian curve. If allowed to settle on a flat surface, SCP-357 will spread until its average thickness is no more than 1 mm. The edge of the mass follows the same Gaussian function that is seen in the meniscus. If solid matter is placed in a container of SCP-357, it will sink into the substance at a constant rate of 0.5 cm per minute. SCP-357 will displace the appropriate volume as any other fluid would. If the solid object is fully absorbed by SCP-357, it will become impossible to distinguish between it and the substance of SCP-357. Theories range from the object taking on the properties of SCP-357 to the object being replaced by a corresponding volume of SCP-357. If a homogeneous pressure of at least 100 ncm2 is applied to a sample of SCP-357, the material will decrease in size at a rate of 1.3 cubic centimeters per minute or more, depending on the magnitude of the pressure. When compressed in this manner, the density of SCP-357 does not change. Rather, the mass decreases at the same rate as the volume. Where the excess mass goes is presently unknown. If compressed to approximately 1 cubic millimeter at room temperature, no amount of force is able to decrease the size any further. Application of vacuum pressure does not increase the size of a sample of SCP-357. The only method found for increasing its mass is via the encapsulation of a volume.